Welcome to our exciting journey into NoSQL databases. Today we're exploring one of the most fascinating topics in modern technology, how databases stay consistent and reliable. Let's start with our first question. What does eventual consistency mean? Eventual consistency means that all nodes will eventually have the same data, but not immediately. It's like spreading news in a small town. Everyone will know eventually, but not at the exact same moment. Think of it like updating your social media status. It takes time to appear on all your friends' feeds, but eventually everyone sees it. Now let's look at our tip section. Perfect for systems where immediate consistency isn't critical, like social media posts or product catalogs. Moving to our second question. What is strong consistency and how is it achieved? Strong consistency guarantees that all reads receive the most recent write immediately. It's achieved through techniques like distributed locking and consensus algorithms. Like a bank account, when you withdraw money, the balance must be immediately updated everywhere to prevent overdrafts. Here's our tip. Essential for financial systems where accuracy is non-negotiable but comes with performance trade-offs. Now, we're diving into advanced consistency with 4 important concepts. First question, what is tunable consistency in Cassandra? Tunable consistency lets you choose your consistency level per operation. You can pick from 1, quorum, or all based on your needs. Our tip here, like choosing delivery speed, same day, next day, or standard. Second question, what happens when a NoSQL node fails? The system continues operating using replication and failover mechanisms. Other nodes take over the failed node's responsibilities automatically. Tip section. Like having backup singers, the show goes on even if one performer is sick. Third question, how does NoSQL ensure data durability? Through replication across multiple nodes, write-ahead logs, and persistent storage mechanisms that survive system crashes. Tip, like keeping important documents in multiple safe locations. Finally, we have a consistency example section with code demonstrations. Let's explore the fascinating world of transactions and concurrency. Our first question, do NoSQL databases support transactions? Yes, many modern NoSQL databases support transactions. MongoDB, Amazon DynamoDB, and others provide ACID transactions, though traditionally NoSQL prioritized performance over strict consistency. Like a shopping cart, either all items are purchased together or none are. No partial purchases allowed. Tip section, perfect for operations like transferring money between accounts or updating related documents simultaneously. Second question, how does MongoDB support multi-document ACID transactions? MongoDB uses sessions and transaction blocks to ensure multiple operations either all succeed or all fail together. It maintains consistency across multiple documents and collections. Now, let's look at our code section with a MongoDB transaction example. Time for concurrency control with 4 essential concepts. First, what is optimistic concurrency? Assumes conflicts are rare and checks for conflicts only when committing changes, like editing a shared document and checking for conflicts when saving. Tip, great for read-heavy applications where conflicts are uncommon. Second, how is locking handled in NoSQL? Most NoSQL databases use lock-free approaches like optimistic concurrency control and versioning instead of traditional locking. Tip, like multiple editors working on different sections of the same book. Third, what are isolation levels in NoSQL? Define how transactions interact with each other. Common levels include read committed, snapshot isolation, and serializable. Tip, like privacy settings, how much can others see of your work in progress? Finally, we have a concurrency example section with practical code. Welcome to MongoDB Mastery. Let's explore this powerful database. First question, what are the main features of MongoDB? MongoDB offers document-based storage, flexible schemas, powerful queries, horizontal scaling, and rich indexing. It's like having a super flexible filing system that can grow infinitely. Think of it as a magical library where books can have different formats, and you can instantly find any book using multiple search methods. Now, let's examine our code section with MongoDB query examples. Tip section. perfect for applications needing flexible data structures like content management systems and user profiles. Second question, how does Cassandra handle large-scale writes? Cassandra uses a distributed architecture with no single point of failure. It distributes data across multiple nodes using consistent hashing and handles writes incredibly fast. Like a massive factory with multiple assembly lines, each line can work independently, making the whole operation super efficient. Tip: ideal for applications with heavy write loads like IoT sensors, logging systems, and time series data. Let's meet Redis, the speed champion of databases. First question, what is Redis and how is it used? Redis is an in-memory data structure store used as a database, cache, and message broker. It supports strings, hashes, lists, sets, and more advanced data types. Think of Redis as your brain's short-term memory. It keeps frequently used information instantly accessible for super fast recall. Let's look at our code section with Redis commands. Second question, what makes Redis so fast? Redis stores data entirely in memory, uses a single-threaded event loop, and has optimized data structures. No disk I/O means lightning-fast operations. Like having everything you need on your desk versus walking to a filing cabinet in another room. Instant access makes all the difference. Tip section, perfect for caching, session storage, real-time analytics, and pub/sub messaging systems. Time for exciting database face-offs comparing different technologies. First comparison, Redis versus Memcached. Redis supports complex data types and persistence, while Memcached is simpler and focuses purely on caching strings. Tip: Redis equals Swiss Army knife, Memcached equals simple but effective. Second, what is CouchDB? A document database that uses JSON documents and JavaScript for queries. Famous for its multi-master replication and offline-first approach. Tip: great for mobile apps that need to work offline. Third, MongoDB versus CouchDB. MongoDB uses binary JSON and is query-rich, while CouchDB uses HTTP REST API and excels at replication. Tip: MongoDB for complex queries, CouchDB for distributed sync. Fourth, MongoDB versus Cassandra. MongoDB is document-focused with rich queries. Cassandra is column family with amazing write performance. Tip: MongoDB for flexibility, Cassandra for massive scale. Let's explore cloud power with DynamoDB. First question, what is Amazon DynamoDB? DynamoDB is Amazon's fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. It's serverless and handles all the infrastructure for you. Like having a self-driving car, you just tell it where to go, and it handles all the complex driving details automatically. Now, let's check our code section with a DynamoDB example. Tip section, perfect for applications that need consistent single-digit millisecond latency at any scale. Second question, MongoDB versus DynamoDB. MongoDB offers more flexible queries and can run anywhere, while DynamoDB provides better managed service experience and tighter AWS integration. MongoDB is like owning a house, more control, more responsibility. DynamoDB is like living in a luxury hotel, everything managed for you. Tip: choose MongoDB for complex queries and flexibility, DynamoDB for simplicity and AWS ecosystem integration. Let's explore real-world applications where NoSQL truly shines. First question, what are common use cases for NoSQL? NoSQL shines in big data analytics, real-time web applications, content management, IoT data collection, social networks, and mobile applications. Anywhere you need flexibility and scale. Like choosing the right tool for each job. You wouldn't use a hammer to cut paper, and you wouldn't use SQL for storing tweets from millions of users. Tip section, perfect when your data structure evolves rapidly or when you need horizontal scaling beyond traditional databases. Second question, which NoSQL database is best for real-time analytics? Cassandra and Redis excel at real-time analytics. Cassandra handles massive write volumes, while Redis provides ultra-fast in-memory processing for immediate insights. like having a super fast calculator that can process millions of numbers per second while remembering everything it has calculated. Tip: combine them. Use Cassandra for storing massive datasets and Redis for lightning-fast real-time computations. Finally, let's discuss Know Your Limits, understanding when NoSQL might not be the best choice. First question: when would you not use a NoSQL database? Avoid NoSQL when you need complex joins, strict ACID transactions, mature tooling, or when your team lacks NoSQL expertise. Traditional SQL databases excel at structured, relational data with complex relationships. Like choosing between Lego blocks, NoSQL flexible but simple connections, and steel beams, SQL rigid but incredibly strong structural relationships. Tip section: stick with SQL for financial systems, inventory management, and applications with complex relational requirements. Final question: how does Netflix use NoSQL databases? Netflix uses Cassandra for massive-scale data storage, DynamoDB for user preferences, and Redis for caching. They handle billions of requests daily across their global streaming platform. Like a massive movie theater chain where each location specializes in different tasks, ticket sales, snack inventory, and movie recommendations all work together smoothly. Final tip: Netflix's architecture shows how different NoSQL databases can work together to create seamless user experiences at global scale. Congratulations! You've completed your journey through NoSQL interview questions. You're now equipped with the knowledge to tackle any NoSQL challenge that comes your way. Retry Claude can make mistakes. Please double-check responses.